assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this problem, there is a damped oscillator as shown here, where there is a block that's attached to a support, and then it ends up going down into a damping solution. The mass of the block is 1.5 kilograms. The spring constant is 8 newtons per meter. The damping force is given by the equation negative b times dt divided by dx divided by dt, where the damping constant is 230 grams per second. The block gets pulled down a displacement of 12 centimeters. So our displacement equals 12 centimeters, which is equivalent to 0.12 meters. And then released. And we're trying to figure out the time required for the amplitude of the oscillation to fall to 1/3 its initial value. Okay, so our initial amplitude can be given by the equation xi equals our amplitude times cosine of omega t plus phi. And then our damping equation that we're going to use to find amplitude is going to be xt, because we're trying to find out the time, where our amplitude is damped, negative bt divided by 2m cosine omega t plus phi. And we're looking for when that is going to be 1/3 of the original value. So our xt, we're looking for when it equals 1/3 of our initial value. So we can substitute in these equations that we've created for these terms. So what we'll have will be xm e to the negative bt over 2m cosine omega t plus phi equals 1/3 xm cosine omega t plus phi. So they're now equal to each other, and we can simplify these so that we would actually end up with a lot simpler bt over 2m equals 1/3. And to be able to solve for our time, we're going to take the natural log. So we'll have negative bt over 2m equals the natural log of 1/3. And then we can solve for t, where in this case t, our time, will equal negative 2 times the natural log, times the natural log of 1/3 m divided by b. And when we substitute in our known values, we have t equals negative 2 natural log 1/3 times 1.5 kilograms divided by our b, which is 0.230 kilograms per second. So we had to change it from grams into kilograms. And we get that t equals 14.3 seconds. The next part of our question is asking how many oscillations are going to be made by the block during this time. And our equation for our angular frequency with a damped oscillator is the square root of our spring constant divided by our mass minus by our damping constant squared divided by 4 times the mass squared. So when we plug the values in, we have that our angular frequency equals the square root of 8.00 newtons per meter divided by 1.5 kilograms minus 0.230 squared divided by 4 times 1.5 squared. And we get that our angular frequency equals 2.31 rads per second. Angular frequency is related to period, in that period equals 2 pi divided by your angular frequency. So when we take our angular frequency that we have just calculated, we'll find that our period equals 2 pi divided by 2.331 rads, giving us 2.72 seconds as our period. Now we found that the total time the time that we're looking for, our t, is 14.3 seconds. So we're going to divide the 14.3 seconds to figure by our period to see how many oscillations we will have. So the number of oscillations will equal 14.3 divided by 2.72, giving us a total number of oscillations of 5.27.